Hi, I'm Mr. Aberdeen, Head of Computing at St. Ivo Academy. Thank you for taking the time to watch this presentation. If there are any questions throughout the whole presentation, please do not hesitate to contact me. My email address is at the end, and we hope to see you studying with us next year.
Computing Pathway, Year 9 Options Evening. Within the department, we have 3 full-time members of staff, Mr. Aberdeen, Mr. Hill, and Miss Hart. The Computing Pathway. Within our department, we offer 2 courses, OCR J277 GCSE Computer Science and the BTEC Tech Award in Digital Information Technology Level 1, Level 2. So what's the difference? There is often a misunderstanding between computer science and ICT. Both are 2 very different areas of our department. So computer science is the science behind how computers work, with students having a strong mathematical background along with an interest in computer programming. Whereas the ICT courses tend to be the understanding and theory behind how IT is used in the world around us, as well as developing practical skills suitable for employment. So what choice should your child make? We would encourage your child to choose the pathway they are interested in. Once we have a full list of students between department colleagues, we will ensure that the choice made by the student is the right pathway dependent on prior attainment, skill sets, and ability. It should be noted, however, for computer science, we'll be strongly recommending students to do this course who are in set 1 and 2 for maths. It should be noted for some students, we may recommend the alternate course if we feel that they are best suited for that course. So option 1, OCR GCSE Computer Science. So GCSE Computer Science. Students will understand and apply the fundamental principles and concepts of computer science, including abstraction, decomposition, logic, algorithms, and data representation. They will analyze problems in computational terms through practical experience of solving such problems, including designing, writing, and debugging programs. They will think creatively, innovatively, analytically, logically, and critically. Understand the components that make up digital systems and how they communicate with one another and with other systems. They will also understand the impact of digital technology to the individual and to the wider society, as well as applying mathematical skills relevant to computer science. So the course is made up of 3 components. We have component 1, computer systems, which is worth 50% of the course. 80 marks is an hour and a half paper, covering systems architecture, memory and storage, computer networks, connections and protocols, network security, system software, ethical, legal, cultural, and environmental impacts of digital technology. We then have the second paper, component 2, computational thinking, algorithms, and programming, also worth 50%, again 80 marks, 1 hour and 30 minutes, and this covers algorithms, programming fundamentals, producing robust programs, Boolean logic, and programming languages and integrated development environments. So component 2 is the more practical element where we then require students to have a strong interest in computer programming and coding. So the third component is a programming project. So practical programming, all students must be given the opportunity to undertake a programming task or tasks, either to a specification or to solve a problem or problems. So during their course of study, students may draw on some of the content in both components when engaged in practical programming. This can be evidenced through an independent coding project or a portfolio of smaller coded programs. So entry requirements. This needs to be the right fit and choice for your child. So it's really important that we have the right sort of students doing the right sort of course. And quite often people will choose computer science thinking it is a subject using computers, often mistaken for ICT. So we will be initially looking for students from set 1 and set 2 in maths. So if your child has a particular interest and is not in set 1 or 2, I would love to hear from them and would encourage further discussions. And you can contact me via email tam.abdin@australiastIvo.org. So option 2, the BTEC Tech Award in Digital Information Technology Level 1, Level 2. So the main focus is on 4 areas. Development of key skills that prove your aptitude in digital information technology, such as project planning, designing, and creating user interfaces, creating dashboards to present and interpret data. The process that underpins effective ways of working in digital information technology, such as project planning, the iterative design process, cybersecurity, virtual teams, legal and ethical codes of conduct. So a lot of content that is similar to the world of work. Attitudes that are considered most important in digital information technology, including personal management and communication, and also knowledge that underpins effective use of skills, processes, and attitudes in the sector, such as how different user interfaces meet user needs, how organizations collect and use data to make decisions, virtual workplaces, cybersecurity, and legal and ethical issues. So the course is made up of the following units. We have component 1, exploring user interface design principles and project planning techniques. It's internally assessed, 30%, so it's a coursework element. There are 3 assignments. Assignment A, investigate user interface design for individuals and organizations. Assignment B, use project planning techniques to plan and design a user interface. And assignment C is to develop and review a user interface. So component 2, collecting, presenting, and interpreting data, is also an internally assessed 30% unit, so another coursework unit. 3 assignments again. Assignment A, investigate the role and impact of using data on individuals and organizations. Assignment B, create a dashboard using data manipulation tools. Assignment C, draw conclusions and review data presentation methods. So component 3, the remaining 40%, is an externally assessed, which is an exam, 60 marks, an hour and 30-minute paper on effective digital working practices. So this covers 4 key areas. Area A, modern technologies. Area B, cybersecurity. Area C, the wider implication of digital systems. And Area D, planning and communication in digital systems. You may wish to take the opportunity to pause the video now to read about these further. So, in summary, the assessments are 1, externally assessed paper, which is 40%, and 2, internally assessed units, 30% each. So as clarified again, internally assessed means coursework, and externally assessed means exam. Thank you for watching the presentation for computing choices. If you do have any further questions with regards to anything such as entry requirements or the suitable course for your child, please do not hesitate to get in touch. You can contact me on my email address tam.aberdeen@australiastivo.org.